You ever wonder how your favorite app just knows you? How it keeps track of everything instantly? Well, it's not magic. It's all about the hidden architecture of our digital world. And today, we're going to pull back the curtain and look at the blueprint, the 7 phases of database design. Seriously, think about it. How does a massive site like Netflix or Amazon remember exactly what you were doing across all your different devices without skipping a beat? That kind of flawless experience doesn't happen by accident. It all comes down to some seriously meticulous planning, and it's all thanks to a perfectly designed database. Exactly. The best way to think about it is like building a house. You wouldn't just show up with a pile of bricks and start stacking them, right? Of course not. You need a detailed plan first. For data, that plan, that essential blueprint, is called a database design, and it's the foundation for everything that follows. So what's the big idea here? Well, database design isn't just about making a list of things to store. It's really about understanding the relationships between those things. It's the difference between just having customers and orders as separate lists and actually defining how they connect so you can ask useful questions like, hey, show me all the orders from this specific customer. That connection is everything. Okay, so where do we even begin? Well, just like building that house, it all starts with the first and maybe most important phase. This is the foundation. You have to know exactly what you're building before you even think about sketching a single line. This is where we sit down and talk to the future homeowners of our data house. We interview everybody, the users, the stakeholders, to figure out the database's real purpose. Are we building a simple website or a huge e-commerce empire? Because if you get this part wrong, well, it's like building a tiny 2-bedroom house for a family of 10. It's just never gonna work. So we identify all the key rooms, our entities like users, products, and orders, and figure out what information needs to live inside them. All right, so we know what we need to build. Now it's finally time to start drafting the actual plans. This next stage is a cool 2-step process that takes us from a really rough sketch all the way to a detailed architectural blueprint for our data. So we're going to tackle this in 2 parts. First up is the conceptual model. Think of this as the big picture sketch, deciding where the kitchen and the bedrooms are going to go. Then we dive into the logical design, where we add all the critical details, like where the windows and electrical outlets should be. One flows right into the other. Conceptual modeling is basically the architect's first napkin sketch. It's high level, it's abstract. We're just identifying our main players, our entities, like students and courses, and drawing simple lines to show how they connect. A student can enroll in many courses, right? That's a classic one-to-many relationship. We are not worried about code or specific data types at all yet. We're just focused on the big ideas. Now, in the logical design phase, that napkin sketch becomes a formal blueprint. We start turning those abstract ideas into structured tables with columns. And a huge goal here is something called normalization, which is just a fancy word for organizing our data smartly to avoid repeating ourselves. For example, instead of typing a customer's address on every single order, we store it just once in a customer's table and link to it. It's way more efficient. And the cool thing is, this detailed plan is still platform independent. Any database system can read this blueprint. So we have this beautiful, universal blueprint. Now it's time to get specific. This next phase is like the architect handing the plans over to a construction company who has to figure out how to build it with their own specific tools and materials. And this slide really nails the difference, right? The logical design tells us what to build in abstract terms. The physical design gets down to the nitty-gritty and tells us exactly how to build it using a very specific system like MySQL or Oracle. We're officially moving from abstract ideas to concrete, real-world instructions. In the physical design, we're making real choices. We're picking our building materials. First, we choose our database management system, the actual software that's going to run the whole show. Then we define the exact data types. Is this field a number, a piece of text, or a date? And, super important, we plan for speed by setting up indexes. An index works just like the index in the back of a book, helping the database find the information you need in a flash. All right, the planning is done, the blueprints are finalized, the materials have been chosen. All that hard theoretical work is behind us. Now it is time to break ground and actually build this thing. This brings us to the next couple of phases, and these are all about action. We're talking about the actual construction of our data house, followed by a super rigorous inspection to make sure everything is built perfectly to code. So let's look at this 2-part action phase. First comes implementation, where we literally write the code and create the database. But you can't just build it and walk away, right? That's why the second step, testing and quality assurance, is so absolutely critical to making sure it all works. Implementation really is the construction phase. We use a special kind of code called Data Definition Language, or DDL, to bring our physical blueprint to life. Commands like create table literally build the structures we've so carefully designed. After that, we load in any starting data, set up who's allowed to access what, and get the whole system ready for action. You would never move into a new house without a thorough inspection, and it's the exact same idea here. We test everything. Does data go in and come out the way it's supposed to? What happens if 10,000 people try to log on all at once? That's called load testing. We even test our disaster recovery plans. This is where we hunt down and squash all the bugs before a single real user ever sees it. Okay, our database is built, it's been inspected, and people have moved in. But the job is not over, not by a long shot. A house needs ongoing maintenance to stay in good shape, and a database is no different. So this final phase, it's a continuous one. It never really ends. We're constantly monitoring performance, keeping an eye on things. We're performing regular backups, which is absolutely critical, and applying security patches. And as a business grows and changes, its data needs to change too. When a new feature gets added to an app, we have to evolve the database design to support it. And that's not a failure of the original plan, it's the sign of a healthy, growing system. And that leads us to a really crucial takeaway. Unlike a physical house, a database is a living thing. The design process isn't some straight line that you finish and then just forget about. The source material for this explainer puts it perfectly. It says design is an iterative process. That just means when a new requirement comes up, we might have to circle all the way back to the beginning, back to that requirements phase, and go through the steps again for that new piece of the puzzle. It's a framework that's built for both structure and change. So from that first little napkin sketch all the way to long-term maintenance, that's the 7-phase journey of pretty much every powerful database out there. It's the hidden structure that powers so much of our digital lives. And it kind of makes you think, doesn't it? Whether it's for a giant company or just one of your own projects, what data in your world could use a better blueprint? Thanks for joining me for this explainer.